Yeah.
Okay, something has happened. Let's see if
it says it's streaming now.
Yeah, but I'm just checking if the YouTube channel is showing something. Yeah, something has come up there also. Okay, excellent. Okay, so we are live on YouTube. I will just keep this one. Let's see.
It says it's streaming now.
But I'm just checking if the YouTube channel is showing something. Yeah, something has come up there also. Okay, excellent. So we are live. Okay, so we are live on YouTube. I will just keep this one. Let's see.
It says it's streaming now.
But I'm just checking if the YouTube channel is showing something. Yeah, something has come up there also. Okay, excellent.
So I think Nirupam, you may want to mute one of the
YouTube. I will just
instruments.
keep this one. Let's see.
It's streaming now.
But I'm just checking if the YouTube. Okay, I think we are all set. It was a bit complicated, but we have it now. The YouTube live streaming is coming with a little bit of delay. I think that's what is expected. Okay, so we have a couple of minutes. We will wait for a few minutes, but maybe we can have the slides already from Sukanya again shared on the screen.
Absolutely, yeah.
Yeah.
And you still see this, right? Are you still able to see this?
Yep.
Okay.
So we'll wait just 2-3 more minutes before we start.
Nirupam, could we also request everybody to mute their mics if they are just listening? I think there are some, yeah.
Preeti, we should start?
I think we should start, yes.
Okay, yeah. So welcome everyone to the 16th Annamani lecture hosted by the Working Group of Gender Equity of the Astronomical Society of India. The talk on the dynamics of social change in academia to be delivered by Dr. Sukanya Chakrabarti. So before we start the lecture, I just want to briefly mention Annamani, after whom this lecture series is based, was a pioneering Indian physicist and meteorologist who carried out path-breaking research in 1950s India against all odds. After completing her undergraduate degree in physics from Presidency College in Madras, she undertook research at the Indian Institute of Science in Bangalore. She worked with C.V. Raman on the spectroscopy of diamonds and rubies and published 5 single-author papers. However, she was not granted a PhD degree by Madras University on the pretext that she did not have a master's degree, ignoring the fact that she had obtained a scholarship for graduate studies on the basis of her undergraduate degree. She took up an internship to study physics at the Imperial College in London, but ended up in specializing on meteorological instrumentation. She returned to India in 1948 and joined the Indian Meteorological Department at Pune. In 1976, she retired as the Deputy Director General of IMD and subsequently returned to the Raman Research Institute as a visiting professor for several years. During her career as a meteorologist, Annamani helped in setting up instruments for studying the ozone layer and wind energy, as well as a millimeter wave telescope at Nandi Hills to study solar radiation. She also wrote 2 books on solar radiation, and this lecture series named after her is being hosted regularly at a regular interval by the Working Group of Gender Equity of ASI. Today we have the 16th lecture of the series on the topic of the dynamics of social change in academia, to be delivered by Dr. Sukanya Chakrabarti, who is a Pei Ling Chan Endowment Chair and Professor at the School of Physics and Astronomy in University of Alabama. To briefly introduce the speaker, Professor Sukanya Chakrabarti is currently Pei Ling Chan Endowed Chair and Professor at the School of Physics and Astronomy, University of Alabama. She works on a wide variety of topics in astrophysics, with her current research focused on developing techniques for precision measurement of dark matter. Her research interest also includes galactic dynamics, radiation transport, time domain and multi-messenger astronomy, and machine learning. She was awarded the Shylock Fellowship for Time Domain Astrophysics in 2019 and the IBM Einstein Fellowship at Institute for Advanced Study in 2020. She is also a member of the Committee for the Status of Women in Astronomy of the American Astronomical Society. And today she is going to talk about the dynamics of social change in academia. This is also being live streamed in YouTube. So I will take this opportunity to mention to the participants in the YouTube live stream that if you have any question or comment for the speaker, please type it in the chat box there, and we will be monitoring it and we will be conveying it to the speaker here. So without any further delay, I will request Professor Sukanya Chakrabarti to please start the lecture.
Thank you very much for the invitation. It's an honor to be giving the Annamani lecture today. So I'm going to be talking with you today about the dynamics of social change in academia. And I'm going to focus really here on astronomers in the US in academic institutions. Okay. So this is the outline of my talk. As Nirupam mentioned, I am a member of the Committee of the Status of Women in Astronomy, CSWA, and I'm the lead for the demographics survey that we carried out last year to try and assess tenure and promotion rates across the country, across the US, with a focus on academic institutions, and also with a focus on individuals whose identities span multiple identities. I want to get to that in a little bit. I want to start by telling you a little bit about how I think about things. So I'll start by telling you a little bit about my work in astronomy and my current work in astronomy, and trying to directly measure galactic accelerations. And this is a project that requires very precise observations over at least decade-long timescales. Now, in that sense, there is some commonality here with trying to understand the dynamics of social change, where the basic unit of time in trying to understand the dynamics of social change is also, I would say, something on the order of a decade. And the surveys that we now have access to from the CSWA do cover about 3 to 4 decades worth of a time baseline. So, while the changes are small, one of the things that I'm going to say is that they do have an effect over time in a cumulative sense. And so that's the good news. I'll also talk about areas where there are still significant disparities. A number of these disparities have been highlighted by this recent report of the panel on the state of the profession and societal impacts from the decadal survey. And this was the first such panel for a decadal, and I'll review some of those results with you because they have motivated some of the focus in our current demographic survey. And I'll end by giving you some of my personal thoughts on the future. So, it may not seem obvious, but the universe does evolve. Stars and galaxies have life histories that are evolving on very long time scales. But change is a really fundamental aspect of our universe. So this is an old quote from Aristotle that is talking about an unchanging cosmos. But this is, I would say, very much at odds with our current understanding of the evolution of the universe, our current understanding of galaxy evolution. So, these days we can carry out fairly detailed simulations of the growth of structure in the universe. And this is from the Illustris simulation, which is a cosmological simulation. That is, it starts from initial conditions that are prescribed from the cosmic microwave background, which show that the universe, when it was a baby, was quite smooth in its appearance, but with tiny fluctuations that were amplified by gravity to produce the galaxies and galaxy clusters that you see today. So here you see the galaxies growing from the cosmic web. Of course, the timescales here are very, very long. Now, aside from improvements in simulations and understanding the life histories of galaxies, the other major improvement has been in large-scale surveys that have shown that galaxy mergers, like the ones that is shown here, are really very common, and in fact, significantly influence galaxy evolution. Now, these, of course, these timescales I'm talking about are very long timescales. And so it's fair to ask, can you really measure changes in the astronomical context? And I'll just tell you a little bit about my work. And so maybe you can see that I am fond of measuring changes, even if they're very small, and even if they're occurring over a rather long time. So traditionally, what we've done in astronomy is we've estimated the accelerations of stars that live within the gravitational potential of the Milky Way from modeling a snapshot of the positions and speeds of stars under certain simplifying assumptions, particularly the assumption of equilibrium that the galaxy isn't changing. But there are many indications now that our galaxy and other galaxies, like the ones that you saw in the movies and in the pictures, there are many indications that these galaxies have had a highly time-dependent history. And this is one example from the analysis of Sloan Digital Sky Survey data that show that there was an asymmetry in the north-south star counts that suggest that the galactic disk is wobbling. And, I sort of come to this from the perspective of someone who's worked, I worked on simulations of the Milky Way, interacting with dwarf galaxies for about a decade before I started working on precision measurements. And so this is a simulation of the Milky Way interacting with the recently discovered Antlia 2 dwarf galaxy. This is the stars, this is the gas. And the one thing that we have in common across these simulations and others that we've done in my group is that the galaxy is changing. And we now, mainly through adapting techniques that have been developed in a number of communities that have worked in precision measurements, particularly in the exoplanet community, in compact objects, we've been able to develop techniques to directly measure that disequilibrium. So it is, I would say, it is possible to measure changes in astronomy if you're quite patient and if you can carry out really precise measurements. This is what's needed to enable so-called real-time galactic dynamics, where one carries out time series precision measurements to directly measure an acceleration rather than estimating an acceleration. The other context where one has been able to measure changes is in the galactic center work that was done by Andre Ghez and others that led to very precise characterization of the mass of the black hole. So I'll just tell you briefly, these three techniques that we're looking at require very high precision. In this case, to use radial velocity observations, we need a precision of about 10 centimeters per second, and we have to do these observations over about a decade to measure the galactic acceleration, because the acceleration that a star experiences, that's a few kiloparsec from the sun over a decade, is roughly about 10 centimeters per second, which is about the speed of a crawling baby and not a very fast baby at that. From analysis of pulsar timing measurements, we were able to measure the galactic acceleration for the first time last year, and from this derive the midplane density, also known as the Oort limit, and the local dark matter density. And finally, another technique is to use very, very precise photometric measurements to look at the shift in the midpoint of eclipsing binary stars, which is, again, the time scale. The basic unit is about a decade here, and that shift is also very tiny, about a tenth of a second. So these seem like very disparate techniques, but the one thing they have in common is their effective precision. Which is comparable to the frequency shifts of an opera singer's vibrato that you can hear with your ear, and the advances in technology that are available to us now allow us to carry out these measurements. So I'm not going to move from real-time galactic dynamics to social dynamics. of course, one of the things I'm trying to say here is that, it takes time to accumulate changes in both of these contexts. Of course, there are a number of differences in these two topics as well. So I'll start with some motivation that we have in designing our survey, our CSW survey, from the report of the panel on the state of the profession and societal impacts. As I mentioned, this was the first decadal to have such a panel. And this is the synopsis here, directly from Appendix N, which is publicly available. So they say that women and people of color, people with disabilities, LGBTQ, non-binary people, and people who hold two or more of these identities. So people who hold two or more of these identities remain extremely underrepresented in senior leadership positions. Now, this is a plot from Appendix N of that report. And on the left here, you can see the number of bachelor's degrees. This is earned in astronomy from 1972 through 2017. The total is shown in the blue line, and the orange shows you the numbers for women in astronomy in the US. And on the right, we have the number of PhDs earned in astronomy in the same time period. So, you can see from this already, and this is further discussed in Appendix N in the decadal survey, that gender representation among astronomy faculty has improved. So specifically, it was shown that women make up about 15% of full professors, which is an increase from about 10% in 2003. Now, there's still, a low representation in an absolute sense, and it would appear that this is not only due to the lag in increasing the numbers of women at the entry level and numbers of women at the postdoc and assistant professor levels, but also to genderized notions of family work, maternity leave practices, which have disadvantaged women in physics and astronomy. Now, one of the things that the decadal survey report highlights is that the situation for racial and ethnic diversity, however, is really pretty dismal. And so you can see here two plots for the number of bachelor's degrees awarded to African American and Hispanic American students. That's on the left, and on the right is the number of PhDs. So now the collective representation here is 8 times that of these groups joined representation in the US. So they're severely underrepresented in US astronomy. Now, I want to talk a little bit about a few metrics that highlight continuing disparities. And you'll notice here that I'm talking here about metrics that really tend to apply more, at the faculty level. Okay, that is the percentage of US faculty by gender and race, funding disparities, the impact of gender and race on teaching evaluations. And I'm doing this largely because, there have been improvements at the entry level. And so I'm focusing on metrics that tend to affect one's success and recognition further down the road. So this is from a fairly recent paper that analyzed data on awards by the National Science Foundation, which in the US is really one of the major federal funding organizations. And here you see, again, long timescales are important for looking at these kind of effects. So we're looking at data from 1997 to about 2019 here. And the solid line is the overall funding rate. So that if you're above the solid black line, you're funded above the overall rate. If you're below the solid black line, you're funded below the overall rate. And the legend for the various demographic groups is shown here at the top. Okay, so you can see that white PIs are consistently, white principal investigators on these grants are consistently funded at rates that are above the overall average. And that's a fairly clear trend over about 2 decades. You can also see that other demographic groups are funded consistently below the overall rate. And in other cases, the numbers have quite a bit of scatter as a function of time. Okay, so there are some demographic groups that are shown here in the thinner lines, okay, and those have, on average, substantially fewer proposals that are submitted from those demographic groups, and the ones that are shown in the solid lines are less subject to small number statistics. So just continuing with this, this was shown here, the difference in the funding rate relative to the annual overall rate over about 2 decades, and this is now a snapshot in time. Okay, and the here the solid black line is showing the overall rate in 2019, okay, for that particular year, and that overall rate is 27%, okay, that's marked in the solid black line for each of these graphs. And so you can see if you have a surplus, you're going to have a bunch of proposals. Above that, if you have a deficit, you're not going to have as many. You're going to have stuff that's empty in that within the solid black line, right? So you can see that here, in the single snapshot in 2019, there is also a significant deficit for Asians, African Americans. So this, of course, leads to cumulative advantages for certain demographic groups and cumulative disadvantages for other demographic groups, which is highlighted in this plot here. So that's the effect of the disparities in funding for the National Science Foundation. Okay, now I'll move on to talking a little bit about representation. Of course, representation and equality are not quite the same thing. I think that's made fairly apparent by the previous paper on funding rates. Now this plot is showing the percentage of US faculty by gender and race. And one of the things that I'm trying to say here is that I think it's important now to carry out these kind of multivariate analyses in demographics survey. That is, there are additional dimensions beyond gender that can affect both representation and equity in our fields. So the legend here is on the bottom. So white males are shown in the solid purple. And by the way, this is, I'm trying to show all of the links directly on the page. So you're very welcome to follow up with them afterwards. And this is specifically for faculty in the STEM and medical fields. Okay, so the legend here is the dark purple is showing white males, and dark purple with the diagonal lines shows white females, and so forth. So, you can see from this that there is significant underrepresentation for Black, Hispanic, Asian Pacific Islander, and American Indian faculty at all levels. Now, this is particularly the case for Black, Hispanic, and American Indian faculty. So that is, they're significantly below the national percentage. Now, one of the things that gets talked about quite a bit in the US, and just about everybody thinks it's not a very good idea, but we still keep doing it. And this is student evaluations of teaching that we do at the end of the semester. It's a convenient way of getting numbers to try to characterize teaching effectiveness. A great many problems have been pointed out about this. And I think this is an area where, women and minorities would really benefit from changes. So this is a recent study that notes that that student evaluations should not be used as the primary metric, as the primary measure of teaching effectiveness, which is, one of the significant components for promotion and tenure decisions. And they argue that the responses that students give to questions of effectiveness do not, in fact, measure teaching effectiveness. This is an example of that. This is a 2016 study which showed that students in classes with professors who actually had low student evaluation scores in their first semester actually did better in a subsequent class. So it does not seem to really be measuring student learning. That's the first point. And the second point, and this has been pointed out by many people many times, is that there is a very significant dependence on both gender and race in student evaluations. Okay, so for example, students rated online professors more positively when they thought the instructor was a man. So, my own view here is that there's an inherent hierarchy in any classroom, right? That is, in order for one to be able to teach something, one has to be acknowledged as an authority in that area. And this notion of authority is, of course, highly genderized and racialized as well. So I'm going to move on now to talking about our the history of the Committee, the Status of Women in Astronomy, CSWA. So I'll tell you a little bit about the history of this committee that I've been serving on for the past few years. And I'll tell you a little bit about previous demographics surveys that have been carried out by the CSWA and what we're doing to try and go beyond that. So the genesis of this committee, you can say, started with Margaret Burbage's refusal to accept the Annie Jump Cannon Prize. Sometime later, the AAS Council set up a working group on the status of women in astronomy. This included, at that time, a number of people, notably Vera Rubin. And shortly after that, the CSWA was established with the charge to recommend to the council practical measures that the American Astronomical Society can take to improve the status of women in astronomy. There have been a number of important conferences and workshops and recommendations that have come out from these meetings are given in some of these links here. So this is, a committee that has engaged really in decades of activism, and they provide both from their long-term members and from the archives a wealth, a library of information. So I'll talk to you a little bit about previous CSWA demographics surveys. So the most recent one, and there have been others before this, but I'll just, in the interest of time, I'll just talk about the most recent one, was done by Meredith Hughes. Okay, and this is a figure from her survey that shows a snapshot in 2013, and this is shown across various ranks here, from graduate student to administrator, for men and women. The absolute numbers are shown in the solid line, in the numbers on the graph. And now you can see, I think that, women here tend to be, on average, more junior, okay, relative to men. Okay, so about 3/4 of women are at the graduate student postdoc level, but men are split more evenly across junior and senior ranks, which is what you would expect. So that's a snapshot in 2013. And, I think, as I've been saying also with reference to galactic dynamics, it's important to look at the trends over time, right? And this is where we can see some positive news. This is showing the distribution of female US astronomers in 1992, 1999, 2003, and 2013. And this is, by the way, Meredith Hughes survey includes both tenure track and research track scientists. And this is across graduate students to full professors. So I'll show you a table in a moment, but let me show you the same figure, but for US male astronomers. And this information can also be distilled into a table here. So this table is showing the percentage of these various different ranks from 1992 to 2013. And one fairly reassuring piece of news here is that at the time that the survey was carried out, the percentage or fraction of female assistant professors was approaching the fraction of female prize postdoctoral fellows. In addition, you can do a survival analysis to see how many, what's the fraction of male graduate students who are advancing, let's say, to the assistant professor level, and is that different from the fraction of female graduate students who are advancing to the assistant professor level. So this is shown here on this top advancement from 1992 to 2003, and on the bottom is the advancement from 2003 to 2013. Okay, so you can see that about 30% of male graduate students advanced to assistant professor. Okay, that's in the top right there. In contrast, only 18% of female graduate students in that time period, 1992 to 2003, advanced to assistant professor from graduate student. Now, if you look down at the bottom, you see a somewhat different picture. Okay, this is looking from 2003 to 2013. And so you see that in this case, okay, over this long baseline, you do see some differences. Okay, so you have about 19% of male graduate students who advance to the assistant professor level, okay, between 2003 and 2013, and about 16% female graduate students who advance to the assistant professor level. Given the uncertainties here, the difference is not statistically distinguishable. So that's some good news. Now, the survey that we're carrying out has a number of questions that are in common with previous surveys, but we have a focus on individuals at the intersection of multiple identities that's motivated by a variety of findings, in particular the synopsis from Appendix N of the decadal survey that we talked about earlier. That's a link to a blog post on our demographics survey. And so our survey here is focused on astronomers primarily at US academic institutions. So one of the things that we're trying to understand is tenure and promotion rates. And we want to understand if individuals at the intersection of multiple identities are disproportionately affected in this metric. So is there a double whammy, right? Because you're a woman and a woman of color, for example. And a later survey will focus on astronomers at non-academic institutions. I'm the lead of the survey that was done last year to assess tenure and promotion rates at US academic institutions. And this has been designed with input from CSWA members, and also a special thanks to Professor Vicki Baker, who is a social scientist based at Albion College. So, there's some questions that are in common from previous surveys. So we're trying to understand how long it's taken folks to advance from associate to full professor. But we also have questions on racial, ethnic identification, as well as gender identification, including non-binary people. We have questions about whether or not people are minorities, if they're a person of color. And we have questions that are trying to understand the impact of maternity leave, of parental leave on the trajectory of one's career, whether it delayed or negatively affected tenure and promotion rates statistically, whether one was required to take on additional responsibilities, that is, teach an additional class because they took maternity leave. That does happen. In my view, that's amounts to not fully respecting maternity leave, because one is entitled to maternity leave, and paternity leave. So you shouldn't have to, just because you took maternity leave, you should not have to assume additional responsibilities to sort of make up for it. Okay. So the survey was carried out over several months. Last year, we had about 2,000 respondents. We will be analyzing the results this summer, and the expected release of our analysis is in 2024. So, yes, absolutely. I believe we will have time for questions at the end of the talk. I'm just about wrapping up here. So I think maybe, you can see that in my view is really not of a static cosmos, of course. It's really more of an accelerating cosmos. And we can now measure those tiny, tiny changes if we're very patient and we wait about a decade. So these long timescales, that's one commonality, that these long timescales that are necessary to see substantive social change is certainly one commonality with measuring galactic accelerations in this new field of real-time galactic dynamics. But of course, the key difference here is one of intention. Right? The intention of people that we've known who have been, who've provided a significant positive influence in our lives. So I would say these are the perturbers, these are the agents of change in this context. So here, strong female role models are incredibly important. And for me, that's my mom. That's her around 1970. That's before she had me and my brother. She was just starting on her PhD. She is retired now, but she was a professor of philosophy. And when I think of a strong person, man or woman, that's who I think of. And so, that reference for me, of course, has helped me tremendously. Now, having mentors in, your professional life is also incredibly important. And I just want to acknowledge a couple of people who've had a really profound influence on my career: Alice Quillen and Steffi Baum. So, I think it's people like this who really drive the changes, the positive changes that hopefully can lead to continuing positive acceleration in this context of social change in academia. So I did want to end on a positive note, but I think I would be remiss if I didn't comment on the rumblings in the US. In some cases, in particular states, legislation has been put forward to end tenure. In Florida, for example, Texas, North Dakota. My view is that, this will disproportionately affect women and minorities. It's to the extent that politicized notions affect tenure and promotion, we unfortunately, I think, can expect very negative impacts if this legislation goes forward on a widespread basis. The one redeeming aspect maybe is that maybe we have enough of a critical mass already of perturbers, these agents of change, that this can be countered. And I'll just summarize the main points from today. There have been improvements in gender equity among US astronomers. However, individuals who are at the intersection of multiple identities are still underrepresented. So stay tuned from the results of our CSWA demographic survey, which should address a number of these questions for tenure and promotion rates, especially for individuals who are at the intersection of multiple identities. And I will end here, and I'd love to take any questions if you have any. Thanks very much for your attention.
Thanks, Sukanya, for this very interesting, nice talk. So now I will request the audience, if you have questions and comments, to please raise your hand, and then I will request you to one by one unmute. So Preeti, maybe you can start if you have a...
Yeah, sure. Thank you, Sukanya. That was excellent. And I loved how you weaved, your astrophysics and activities of CSWA. I think it is finally all related in some sense, I think. So I completely agree with the way you wove those two. So my question was, when we started the working group for gender equity, we definitely were highly motivated by the activities of CSWA. And we, in fact, all the resource material, I mean, that has been very, very helpful for us, actually. And we've tried to do the same for us. We are not even, we actually got approved only in 2015. So we are still very young, a young group. So my question actually is something that we kind of struggle with, is about how to keep ourselves relevant. And I mean, it's very difficult sometimes for us to sustain our activities. And so how does CSWA do that? I mean, how do you keep yourself relevant? Do you feel, I mean, is there any sense from the WAS that now that things are better, CSWA is not needed anymore, for example? I mean, do you get any sense like that? And yeah, so just your comments on this.
Right, yeah, that's a great question. So, there are, of course, a number of things that we do on a fairly routine basis, as I imagine you do as well. We have regular monthly meetings. A number of us are also involved in the overall strategic plan, IAM. And so that's a smaller group of us who meet more regularly, and we sort of try and hold each other accountable in bringing our projects to completion. We try to interface with other committees that are more focused on minorities as well. I didn't really talk about the other main projects of the CSWA's strategic plan, but one of those really significant projects is on harassment and bullying. I think I would say that that's still ongoing in our field in the US. A lot of the positive change that I've seen in that context has been driven by early career astronomers. And that's wonderful. It's, I wish it was more the burden was more widespread, but it's also incredible that they've spearheaded so many initiatives. So the issues of, I think, bullying and harassment may be a little bit different now. It may not be as explicit, but I would say it's still fairly prevalent. That is, many people report gender harassment, some maybe explicitly sexual harassment, but there are many instances of reported bullying and many instances of reported gender harassment. There's also, one of the other projects, and I sort of alluded to this when I was talking about the difference between achieving equal representation versus equity, right? They're not the same thing. Asians are not underrepresented in academia, but their funding rates are severely low compared to white PIs. And so that's, you can see that highlights the difference between representation and equity, right? I mean, there can be a lot of people in a field, but they're not getting the same kind of recognition, or they're funded at very different levels from the dominant group. And so another project is looking at, for example, the gender differences, the number of people who are doing press conferences, the percentage who are men and the percentage who are women. And there is a significant difference there as well. So it's, I guess really what I'm trying to say is that I think there have been sort of, if you think of it as sort of a ladder, right? There have been entry-level improvements. There have been improvements at some level in representation, but it's still not, that's still not the same thing as having equity in the field. So I would say that the discussion should be a little bit more nuanced. And so, that's why the metrics that I was pointing to are not only about representation, they're about success, right? Who's getting funded above the overall rate, whose teaching scores are considered really good by the metric that you're using, and so forth. Now, does that answer your question?
I think it does. I think it does. I see that, it has taken CSWA 20 odd, years, that now the representation has improved, but then the situation on the ground is obviously not exactly,
That's right.
is not exactly where you want it to be. Yeah, I see that. And I think this will be a problem that we will face as well. I mean, if we do, I don't think we have, I'm not sure how much influence we've had on our astronomical society, but if we do make some changes, I think this is the next set of things that will be, that will come up. And yeah, it'll be good to see how to address this. Yeah, thanks.
Thank you for the question.
There is another hand raised. So Busatsi, please unmute yourself and go ahead.
Yeah, hi. Thank you. Sabyasachi here from Indore. Thank you
Hello.
so much. Hi. Thank you so much for your talk. Yeah. So thanks so much for your talk. I am glad that ASI has taken this initiative. I was also very happy to, when you were answering Preeti, that you mentioned about your mention of bullying and harassment. Because that is what my comment was about. I was going to say that bullying and harassment are very much part of this. And at least in India, in my more than 10 years of experience in being a faculty member, I can say very clearly bullying and harassment are very, very explicit in India. And it is, at least in India, and it's not, it's a huge problem. It's a huge unstated problem. So,
Yes.
and I know that women are more affected by it, but even male scientists are, and it eventually all of it goes to, if a male scientist is affected, then their spouse is also affected. So eventually it does boil down to all of that pressure going to women. So I'm glad you've raised this. I have no idea how to address it. I can give n number of examples from my experience, but that perhaps won't be as helpful. Maybe we can think about it a little bit more. One thing I do have an example about, and something that I'm, not just me, my family is struggling with, is I have a niece who is 10 years old and that I'm very attached to, and so she's fantastic. I mean, she's way smarter than I am. He's smarter than all of us, but we are having the hardest time keeping her away from, and I'm sorry to say this, from things like dolls, which are available all over the market. But it's not just the dolls. We've had to change her school twice because the atmosphere in these schools is absolutely, against the girl child doing anything except things like playing with dolls and playing kitchen and so on, which I have no problem with in principle. But what I want is for her to be able to talk to scientists like you and Preeti and others, so that she knows there are so many better things to do than just, you know, yeah. I really, I'm really angry about it, as you can see, because we're really having a tough time keeping her away from all of this. Not because, we want her to become a scientist. She may or may not become a scientist. That's okay. But at least I feel we should give her the opportunity to excel in science, to make a career in science, if that's what she wants, or in arts, or wherever. But that should not be dictated by is society hell bent on, or schools, forget about society, schools hell bent on, up, applying certain norms to the two different genders. You see where I'm coming from. Is there a way out of it? Is there a way that you can talk to, you guys can talk to these girls, and maybe that'll encourage them to, I don't know, do a number of things. You see what I'm saying?
I think so, and I, of course, firstly, I agree completely with your broader point on bullying and harassment. And I would say, as I mentioned before, but I'll reiterate, I do think it is still quite prevalent in the US academic community as well. It is in astronomy, certainly, and in physics and astronomy. It sort of maybe has a somewhat different face than it had a few decades ago, but it by no means is gone. And it certainly, the issues have not been rectified. In some cases, there have been sort of token attempts, and that's maybe even worse than,
Yeah.
than ignoring the
Yeah.
problem. So, as far as encouraging young kids, I think, in my personal experience, as I said, I think it's having strong female role models. In my case, I was very lucky to have that early on, and also seeing that across your world, whatever your world happens to be. And I was born in India, but we moved here when I was in middle school. So I've spent my professional life here in the US. So I'm not qualified to talk about the situation in India. It may be interesting to think about collaborations at some point between various committees on gender equity in India and in the US. That's one possibility. I'll say I did play with dolls as a kid. I don't, but I think it's a bit, as you say, it's really having exposure to other things, right? It's
Yeah.
that's what it's about, so that they can make their own choices. And it's really about having that agency of choice that, so unfortunately, I don't have a silver bullet for that.
No, of course, of course. No, but it's good to know that you're thinking about addressing these. Maybe, as you say, we can later on talk about how we can organize online talks maybe for teenage girls in India
Mhm,
to meet up their role models in India and
mhm,
abroad and the
mhm.
US. So thank you very much.
Thank you.
So Shukun, I have one question. So so overall in your presentation, there are some of the things which are positive, moving in probably slowly in the right direction, and then there are few which are not so much, and then a lot more things are yet to be done on those fronts. Um, Now, this is the situation that has come out from this demographic survey in the US. So, is there a thought about sort of expanding it more, maybe in collaboration with other bodies in different countries, things like
Mhm.
maybe IAU or other international bodies, where a more global picture may emerge, that whether in some of the matrices there are really slow improvement which is happening, and then there are others, are there some common thing which emerges out in different countries? Global, is there a global thing which comes out? So do you have any plan on that direction, or do you know if other groups or people who are sort of trying to do something on that line?
Right. Yeah, that's a great question. Um, so, we started out with a fairly narrow question. I mean, I think we've still been able to go beyond what previous surveys have done, but certainly our focus was relatively narrow in that we are looking at U.S. Astronomers and even really only in primarily academic institutions, and there's now others in CSWA who are about to carry out a similar survey for astronomers in non-academic institutions, like in national labs, for example, and I think the connection to the world at large is also an important one, and we ought to discuss it. And it would be really interesting to see trends across not only long time baselines, as you say, but also across different countries globally. So I think that would be a really interesting project.
Mm-hmm.
But we haven't yet we haven't yet made any progress on that. But I can certainly bring it up in discussion. I think that would be a really interesting project.
Sure. Yeah, and since I do not see any other hand raised, okay, yeah, Preeti, please go ahead.
Sorry, Nirupam. I just wanted to ask one final thing. Was this how binding are, for example, the recommendations of CSWA on the AAS activities? I mean, is there something? I mean, are they? I mean, from our side, I can say we don't have much of an influence on the ASI activities. We do try to do these workshops where we sensitize the people who attend. It's obviously not mandatory, and so it's a small group of people who attend these meetings, and so we do those sort of activities. But I mean, how much power does CSWA have, for example, in influencing AAS activities?
Yeah, that's a really good question. I mean, of course, we're a committee, right? So we're not part of, we're not the executive officers of the AAS. So what we do, like any committee, okay, like any committee, we make recommendations. And it's, I think, the fact that there's significant visibility of the CSWA is a really good sign in showing that the recommendations that we're making are considered quite seriously by the AAS. There's there are, of course, many things that we cannot do, right? We can't, we don't have legal authority, obviously, if someone has there's a harassment case, we can't provide legal advice. But there's a difference between that kind of someone acting in that capacity and someone acting as an ally, right?
Yep.
So we can certainly act in that latter capacity.
Yep.
And in some cases, that's enough for a victim to move forwards to some level.
Yep.
Right. Even where they are at.
Yeah.
So, it's a complex question. I think there are certain things that we could do to improve on that front, and there are things that we're looking into now to try to move forwards.
Right.
Yeah.
Pardon?
No, sorry. I think there were two people who I think had their mics unmuted. Sorry. Yeah.
Yeah, I think there is another question or comments from Priya. Priya, please unmute and go ahead.
Yeah. Thanks, Narupam. So, hi, I'm Priya. I'm the co-chair of the Women in Astronomy at International Astronomical Union. Yeah. And what I have been working on a lot with the thing, I mean, all these issues do exist, but I was trying to tackle the problem in the sense of doing training programs. So I did some 5 training programs for women, which were like 5-day long things, starting off from Python and coding and, doing specific data analysis and things like that. And that was actually very effective because a lot of the women, we started it in COVID times, so it was online. So a lot of the women almost from all over the world who participated, many of them benefited a lot in terms of, in their PhD programs or, in managing to analyze things because, if they could network and figure out how to do things. So I thought even that is a very important, it is a very important aspect of, trying to handle the problem in the sense, because, that's what people need, right? They need the skills so that then they can stand out and, get recognition, right? If you have a skill, then people will take you, right? They need you, so they will take you. So if they have special skills, women will definitely be taken up as a research scholar or postdoc or whatever it is. So what are your thoughts on that? Have you all been doing anything of that in sense of, helping the situation?
Yeah, it's a really good point, and thank you for asking. So, of course, education is the great equalizer, as you say. Now, I'm involved with those kind of efforts, but in other areas. So, what comes to mind, one that I'm most directly involved with is our own program that we're carrying out, which is from NSF Collaborative Grant. And we, together, this is with Dan Huber and Robin Sanderson, we've been mentoring Native Hawaiian students. And, these are undergraduate students, and both men and women. And what we found by doing this over the last couple of years is that it's very useful. And this year we're beginning basically a Python boot camp to try and get them up to speed. And we expect they'll also, once they go through the boot camp, they'll also make more progress during the RU program, the research experience for undergraduates.
Yeah.
So that's what I've personally been involved with directly, and there are a number of programs that are similar to that in the US. So I think one of the big ones is the pre-MAP program at University of Washington, which is designed to provide, coding experience, technical expertise for incoming students
Mhm.
to help them down the road during the rest of their undergraduate career. And really, it does, as you say, it translates down the road as
Because
well.
it can kind of combine the effect of, a mentor and a role model who, a person is, being effective in their lives, right? Because I think many of these young girls, that's either they are underconfident because they do not know how to run softwares, and, so that they kind of tend to, shy off from
Yes,
the thing, right? Because they don't know how to do it. So,
absolutely. Yes. Yeah, that's critically important. Yeah.
yeah, thanks.
Thank you.
So, Sukanya, I have another quick question. So you mentioned about this teaching evaluation by the students,
Yes.
and of course mentioned about some of the shortcomings of that. But in a way, it's essential evil that we are living with, because that's one of the way of measuring whatever it is, right? So is there any discussion about what can be the viable, better alternative of sort of also getting that evaluation? I mean, in a way, you'd like to have the evaluation of, teaching,
Right.
while taking some decision in whatever way. But what will be a viable alternative option? Is there some thoughts on that?
Yeah, that's a really good question. So, I think the studies that have been done are really trying to emphasize that it should not be the primary metric by which teaching effectiveness is judged. Okay, so I think, if you have it as, let's say, one component, okay, but you are sensitive to the influence of gender and race on those evaluations, and you include other metrics that maybe take a little bit more time to do. And one of the reasons these things are so widespread is that, it's trivial to do them. It's really easy. It's really fast. On the other hand, if you have, let's say, your colleagues, faculty members, your colleagues in your department or even other departments who come into your class and assess your teaching, that's more work. Okay, but I think that can often lead to, I would say, a more certainly experienced viewpoint and a more critical and often constructive viewpoint on teaching effectiveness rather than teaching satisfaction. So what a lot of these surveys are saying is that the student evaluations of teaching are not measuring teaching effectiveness, right? I mean, the 2016 survey that I referred to shows that students who rated professors low in one semester in their later semester in continuation of the class and that sequence are actually doing better. So that, I think, it really shows that it doesn't have much to do with teaching effectiveness, but satisfaction, right? And often the issue here is that, this type of disproportionately low scores for women often happens in departments where there is a significant gender disparity, because they're really standing out as faculty, and as I said, in order to teach, right, when there has to be there is some, in any classroom there's an inherent hierarchy. One can't teach unless you're acknowledged as an authority, and that concept of authority is very genderized.
Sure.
So I think possible alternatives, and this is not to say that they need to be thrown out, I mean, completely, but I think the studies are really trying to say that they shouldn't be the primary metric for gauging and that like as an alternative, one can consider feedback from colleagues, right?
Okay. So let's see, do any of you have any other questions, comments, anything? Okay, if not, then let's thank Sukanya again for this very interesting talk today, as well as taking her time for this long discussion. So thanks a lot for joining us.
Thanks very much for having me.
Okay, so with that, I'll close the session. Thanks everyone for joining today, and have a good evening, good day for Sukanya.
Bye-bye.
Bye.